So for this video, we're going to focus on infinite geometric series. So a quick reminder on what a geometric series is that to get from term to term, we multiply by some common ratio r. Okay, so r is a common ratio. So if an infinite series, geometric series, converges, it means that even though it's infinite, the sum will reach some finite value. So if it converges, that means that the common ratio, the absolute value of it is less than 1. And then to find that finite value that it would converge to, we use this right here, okay? A over 1 minus r. That means that the interval of convergence then for r is between -1 and 1. If the absolute value of the common ratio is greater than 1, it means the series diverges. So the sum does not reach a finite value. So looking at these examples here, we have to determine, does it converge or diverge? And if it converges, then we can find the value. So remember, if the absolute value is greater than 1, it's diverge. And if the absolute value of r is less than 1, it converges. So looking at this example here, I need to find what the common ratio is first. So looking at this, I can see that I multiply by a -1/3 to get between all of these values. So if that is the case, so r is -1/3, well, the absolute value of -1/3 is less than 1, so it converges. So since it converges, we're now going to find what finite value it converges to. So a is going to be 2. So we use this, a over 1 minus r. And that's not a very good a. So let me fix that a. All right. So 2 over 1 minus that -1/3. So in this little formula here, you still use the value of r. You don't use the absolute value. So we have 2 over 4/3. So 2 times 3/4 would give me 3/2. So that would be the finite sum it converges to. If I look at this second example here, again, I need to find what is the r value I'm multiplying in between each term. And in this case, it is 0.1. So again, the absolute value of 0.1 is less than 1, so it converges. So when we do this, we can now do 0.2 over 1 minus 0.1. 0.2 over 0.9 gives me this 0.2 repeating. So that's the value that we find here. Now with this one, we can write out the sequence, or I can manipulate it to where it's r to the nth power would give us that common ratio. So using exponent rules, I am going to rewrite this part here as pi over 3 to the power of 1 times pi over 3 to the power of 10. So it tells me we start at pi over 3 in our series, and then we multiply by pi over 3 to get to each spot. So we look at this like so. So if we think about this here, then that means our common ratio is pi over 3. Well, the absolute value of pi over 3 is greater than 1, so it diverges. So it does not have a finite sum it would reach. So let's do a couple more examples with some manipulation here. So again, we're going to manipulate it to see where would it start, and then where would the series start, and then what is the ratio to get between the terms. So I'm going to rewrite this 5n to the -1 as 5n times 5 to the -1st, and then this 9/10 to the n did not change. Well, now that I've done this, well, we know 5 to the -1st is 1/5, and since these are both raised to the power of n, I can multiply them to be raised to the power of n. So this gives me 1/5 times 4.5 to the n. So our series looks like so. Well, when we look at it this way, it's telling me my common ratio is 4.5. Well, the absolute value of 4.5 is greater than 1, so it diverges. All right, last example to determine if it converges and diverges, and then what does it converge to. So same thing like last time, I'm going to manipulate this part here. So that becomes 1/3 to the n times 3 to the negative first. So we can split this up. Well, 3 to the negative first, or 1/3, sorry, to the negative first is going to give me 3. And I can rewrite this as 1/3 to the power of n. So like last time, since these are both being raised to the power of n, it now becomes 2/3 to the n. So our series looks like this. Well, then now here I can quickly identify that r is 2/3, and the absolute value of 2/3 is less than 1, so it converges. So now I need to find what finite sum it would reach. So a is going to be 3 over 1 minus 2/3. Well, that becomes 3 over 1/3, which becomes 3 times 3, so it would reach a sum of 9. All right, so that is how we determine if it converges or diverges. So then now, what if we're given something, and this should actually be a 1, my bad. What if we're given something that looks like this, where our series has a variable in it here where we need to determine when will it converge and what values of x will it converge to. Well, to do this, the first thing we need to do is prove that it is a geometric series. So I can rewrite this here as negative 5x to the nth power. So when I say we want to prove that it is a geometric series, I'm going to scroll up really quick, is I want to prove, can we rewrite it as some term that keeps being multiplied by the same common ratio over and over again. So we are going to try to make it look like this. So I'm going to scroll back down. So to do this, well, when we are starting at 1, sorry, like I said, that should be 1, we can write this as negative 5x to the first, and then keep going, so 5x squared, and then it would be negative 5x to the third, negative 5x to the fourth, and so on and so forth, okay? Then we should see, can we factor out some a, so then that way we can quickly identify what is the r here? What's the common ratio? So to do that, we're going to factor out negative 5x, and we get 1 plus negative 5x plus negative 5x squared plus negative 5x to the third, and so on and so forth. So we can now see that yes, it is in fact a geometric series, and this would be the common ratio here. Okay? Well, since it's the common ratio, we need to know that the common ratio has to be less than 1 for it to converge. And so I want to find exactly what values of x will do that. Well, thinking about absolute value, well, that negative goes away. So it's the absolute value of 5x has to be less than 1. Well, since I can do that, I now need to be able to say that this interval of convergence goes between negative 1 and positive 1. And now I have an inequality I can solve to find what values of x are going to give me a series that converges. And it would be from negative 1/5 to positive 1/5. So that would be how we would do that one. And that's because it starts here at 1. So kind of similar idea is when will it converge for what values of x will it converge? Well, if I start at 0, or n is 0, so x plus 2 to the power of 0 plus x plus 2 to the power of 1, x plus 2 to the power of 2, x plus 2 to the power of 3, and so on and so forth, we can see then that our common ratio here is x plus 2. So like last time, we have to say the absolute value of x plus 2 has to be less than 1 to determine what values will it converge. So we're going to solve this inequality. And we see that it will converge in this interval. All right, so that is infinite geometric series.